So let's start with the sonometer experiment. The aim of the experiment is to find the frequency of alternating current in India using sonometer. So the principle of the experiment is that in each cycle of AC the sonometer string is pulled and released twice, and the second one is at resonance the frequency of AC, that is the external frequency, is equal to the half the frequency of the fundamental node of vibration of the stretch string. So now what does it mean? So you can see that this is the sonometer setup and this is the power supply, and here in India it is 220 volts and 50 hertz. So you have to find that the frequency of AC is 50 hertz. Now this is the step down transformer. So from 220 volts it has been stepped down to 6 volts, and this is an electromagnet under which there is a sonometer wire which has through the pulley it will go, and a mass has been hanged to provide tension. So now what is happening, because the current is AC, that means it will change direction so many times in 1 second. So that's the frequency f which we have to find. So in one time period, so you can see here, in one time period from 0 to t, the current will change direction twice. So that means in one time period, so the current will go from top to bottom and then bottom to top. That means it's one cycle. Now you know that this is a copper coil. When current flows through a copper coil, it will produce magnetic field. So when the current is flowing from top to bottom, maybe this side it is north pole and this is south pole. When the current flows from bottom to top, this becomes north and this becomes south. So basically in one cycle the poles, magnetic poles, will flip twice. So when this top side is north pole, maybe the sonometer wire will be pulled towards the electromagnet. When the bottom side becomes north pole, maybe the string will be released or pushed away. So every time the poles flip, the string will also vibrate like this. Now you can see now that for a given cycle, as I told you earlier, in one cycle, since the current changes direction twice, so the frequency of flipping of the poles is twice that of the AC frequency. So that's what is said here. At resonance, here in each cycle of AC, that means from 0 to t, that is one cycle, in each cycle of AC the sonometer string is pulled and released twice. Why twice? Because the north and south pole of the electromagnet will flip twice in one cycle, that's why. Now the second part is at resonance the frequency of AC, that is the external frequency of the sonometer, is equal to half the frequency of fundamental mode of vibration of the stretch string. Why half? Because of the same reason as I told here. Now what is resonance? You already know that when the external frequency of electromagnet is matched with the natural frequency of the string, resonance occurs. At resonance the vibration of the amplitude will be maximum. So I can change the natural frequency of this wire by changing length of the wire or by changing the tension. Now for a given tension, I will calculate the length at which the resonance will occur. Now how to measure the length? You have to measure the length between the knife edges. This is the knife edge, this one is the knife edge, and one more knife edge. Now how to measure the length? You have to see the middle portion of the knife edge is the position of the middle portion of the knife edge, which is around 94.8 minus whatever this position, it's around 6. So that would be the resonating length. That's how you measure the length. Now what is the formula? There are two methods. Graphical method, this is the formula where mu is the mass per unit length of the sonometer wire, and we have to calculate the slope of L square versus T graph. L square is the resonating length, T is the tension in the wire. If we calculate the slope, we can put it in this equation. We will directly get the frequency of AC current. Now the second method is to put this equation, which is frequency external is 1 by 2L times under root of T by mu. Now what is the difference between these two? This frequency, that is the frequency external, will give you the frequency of flipping of the north and south poles, and here you will get directly the frequency of AC current itself. Now so you can choose, I will show you both. So you have to write the first the principle, formula, and then nature of graph if you have a graph in your experiment, otherwise the diagram of the experiment. Now let's do the experiment. This is the observation table. So you have to, the first column is tension, that is the tension in the wire. So which is T is equal to M into G. That is the SI unit is newtons, and the resonating length in meters, and then external frequency we have to calculate using this formula. So I'll switch on the sonometer. When you switch on the sonometer, the wire should already start vibrating slowly. Now it's not yet at resonance, we have to bring it at resonance by changing the length. I am decreasing the length. At first I'll keep both the knife edges at extreme position, then I will decrease the length by moving the knife edge. Either of the knife edges you can move, or both of the knife edges you can move. So at some point resonance should happen. At resonance you can hear the noise, or the wire will vibrate, sonometer wire will vibrate with maximum amplitude. So you can see that it is happening now. Probably you can't see, but you can hear it. So now the wire is vibrating with maximum frequency. So this is the resonating length. So as I said earlier, you have to just measure the length between the knife edges, which is around 71 minus 5.5 or something. So I have already taken the readings. It's around this one. So we'll get 64.9 centimeter for 24.5 newtons of tension. So why is it 24.5 newtons? You can see that each slotted weight is 0.5 kg, and there are 1, 2, 3, 4, 5 slotted weights, so it's 2.5 kg, and 2.5 kg into 9.8 will give me 24.5. So like that you have to do the observations for 5 more tensions by removing each slotted weight every turn. Then you have to calculate the frequency using this formula. So you will get, and then you have to take some kind of average. So add everything and divide by 5. I'll get 50.32 hertz, which is, sorry, I'll get 100.64 hertz, and then I have to divide by 2, because whatever 100 hertz I got is the frequency of external sonometer. That means it is the frequency of flippening of the poles, not the frequency of AC. Frequency of AC is this divided by 2, which is 50.32. In India, as I told you earlier, it is 50 hertz, so we are getting the actual value. Now from the graphical method, what you have to do, so I have taken the same reading, and then you have to calculate L square. And one more thing, mu value will be given here. You can see that this is the formula. You are calculating L, T you would know, mu value it will be given in the experiment itself. So you will be calculating for this tension, what is the resonating length, and L square. Then you are going to plot a graph between L square and T, which I have already done. So you can see L square is on the y-axis and tension is on the x-axis. So L square I have taken 900 to 4500 into 10 power minus 4. So when I plot it, L square versus T, I'll get a straight line. I have to calculate the slope. When I calculate the slope, I'll get 0.0155, that is the slope. So once I plug it in here, slope as 0.0155 and mu value, which has already been given here, I'll get 52.7 hertz. So there is some difference between these two, although the readings are same. That is because when you plot it, there will be some errors. So that's okay. So 52.7 is close to 50 hertz. So by both the methods, we are getting the frequency of AC in India using sonometer.